Tēnā koutou katoa. Welcome to our webinar today, where we will be presenting on our common quality consultation, addressing frequency and voltage issues. My name is Sina Tulavai. I'm going to be a bit of a facilitator today, but I'm joined here by our experts, Philip, Vong and Sheila. I'll be handing over to Sheila soon, who will do proper introductions. I'm just going to run you through a few webinar etiquette things. You'll see up the top of your screen on the left, you will have a chat function and a Q&A function. If you could pop any questions that you have into the Q&A function, because that's where we will be looking at them, and we'll be answering those at the end of the webinar, so after the presentation ends. Think about your questions throughout and just pop them in at any time. We'll come to those at the end. If we don't get to any of them, we'll come back to you in good time. All right, so I will pass over to Sheila now, who will do proper introductions and get us stuck into the webinar.
Thank you, Sina. Kia ora, everyone, and welcome to this webinar once again. Thank you for taking the time. I'm Sheila Matthews, and I manage the Future Security and Resilience team here at the Electricity Authority, Te Manahiko. And with me today to present, we've got on the left, my left, Philip Beardmore. He is a director at Strata Energy Consultants. Philip has got extensive experience in regulation and in the design, implementation, and operation of energy markets, not just in New Zealand, but in Australia and Asia too. And we've got Dr. Vong from System Operator. Vong is a principal engineer in the Power Systems Development team, and he provides specialist support to asset compliance and the Power Systems operations teams there. Vong has also been the lead for the FSR work from System Operator side. So he has worked a lot on, or he has facilitated all the studies that have informed today's papers. So if you have had a chance to go through the papers and you have any questions on studies, raise your hand. Yes, the purpose today, what we want to cover is the purpose of today's webinar. I'll then talk about the context for these consultation papers that we're taking you through. I'll talk about how you can make a submission, and then I'll hand over to Philip to go through an overview of the papers. And there will be time at the end for questions. I'm sure we'll have enough time. So as Sina said, please pop them into the Q&A function as we go along. You don't have to leave them for the end. And if we can't get to them, we will respond to you later. Also, we will be putting the webinar, the recording, and the slides on our website after the session. Right. So the purpose of today's webinar is to provide the context for and the purpose of a suite of consultation papers we published towards the end of last month, the 25th of June. There were 4 papers we published, a cover paper that gives an overview of the 3 consultation papers that have accompanied it. Today's webinar is on the consultation on options to address frequency and options to address voltage. There is a 3rd paper, which is a discussion paper, and that's on harmonics. It's on the governance and the management of harmonics. And the reason it's a discussion paper is because it's really too early to go to options in the area of harmonics. Harmonics is there's very little regulation at the moment in New Zealand. It's very light in the code. And so we considered it was too early to start looking at options to address harmonics. So that is a discussion paper. We did a webinar last week on that, and it's on our website in case you'd like to see that. There's a lot of questions, and it was a very good session. So yeah, that's the purpose for today's webinar. I'd like to say that this is just one of the projects we're working on in the authority. There are lots of other work streams also happening to address other issues on the power system. A bit more about the context for this. So the power system, as we know, or in the past, was centralized, a lot of synchronous generation, or rather only synchronous generation mostly, and power flows were in one direction, unidirectional. But now we've got new technologies coming on. We've got distributed energy resources connecting to various parts of the power system, and a lot of inverter-based technology connecting in the form of wind, solar, and batteries. So as we transition, more of this is coming onto the power system, and with that come challenges, technical challenges. You've got bidirectional power flows now, and we've got the added challenges of the characteristics of inverter-based technology. We also have a lot of new participants coming on, consumers. They're becoming prosumers. They can put power back into the grid, not just take power off the grid. And also, we've got a greater reliance now on intermittent and variable sources of generation with wind and solar. All this is contributing to, bringing challenges to the power system, and it could affect the security and reliability unless they're actually addressed in a timely manner. The code in its current form is based, as I said, on the centralized, synchronized power system. It needs to be reviewed. We need to get settings in place that will address these challenges. So next slide, please. And here comes the FSR program, so the Future Security and Resilience Program of Work. This was initiated around 2022. We worked with the system operator and we asked for what they thought were the challenges and opportunities as the power system transitions to a low emissions economy, or as New Zealand transitions. And we got a list of 10 activities and put a roadmap together. This was published in August 2022, and it's on our website. So what it showed was 10 broad areas or activities that needed to be addressed. Now, with resources and funding budgets, we can't obviously address all of them. And also some of those activities were not going to become an issue right in the immediate future. It's a 10-year roadmap, in the immediate time. So we then asked what the highest priority should be that we should address. And it was Part 8 that was indicated, a review of the common quality obligations in Part 8 of the code. So if anyone's seen the code, it's a huge document, lots of parts, and even Part 8 is actually quite extensive. So the focus of this project is on the common quality obligations in Part 8. And so that was identified as the highest priority. We took that roadmap to stakeholders later in 2022 to ask if they agreed with this view and the roadmap. And they did, largely they did. However, they also identified system operations and said this is another area that needs to be reviewed, because as the power system changes, the system operations will also have to evolve. And then we got another work stream out of that, which is on your bottom right there, future system operations. So if you look at the roadmap, you won't see it there because it was something that came up as a result of further discussions with stakeholders. And at the top, we've got the FSI indicators. Now, what are those? So in May last year, we published a set of 9 indicators, monitoring things like EV uptake, the amount of DR connecting. We get that information from the registry. We are looking at system inertia and a couple of other indicators. Now, why are we doing this? Because that's what we're using to inform the prioritization. So when we look at the indicators and if we see something changing faster or sooner than we expect it to, for example, system inertia, then we'll have to look at reprioritizing our work to look at that problem. So that's why we've got these indicators. They're also on our website, and we refresh these indicators every 6 months to keep them current. Next slide, please. Our statutory objective at the authority is to promote competition and to ensure that we have a reliable and efficient power system. And this in turn benefits consumers. Now, in late 2022, we also got an additional objective, and that is to protect domestic consumers and small business consumers. And so why I'm talking about the statutory objectives is because all our work streams have to align with our statutory objectives. And as we go through the next slides on Part 8, on this review, you will see that getting the settings right and the common quality obligations is going to be really important to ensure we have a reliable and secure supply. And therefore, consumers get the benefit out of this. So that's a bit about our statutory objective and how our work aligns with that. Next slide, please. Coming to Part 8 now. That's what this is all about. So last year we started looking at what the key common quality issues are. We worked with system operator, and in April last year, we published an issues paper. So we identified 7 areas of common quality issues that we had identified. The first one was around frequency. The next 3 were around voltage. The 5th one is on harmonics. And then issue 6 is around information. It's around network information, visibility of information, and then lastly we had the code terminology. As I just said earlier, the settings in the code as they are not quite fit for purpose to enable these new technologies, bidirectional power flows and inverter-based technology. So there are some missing terminologies, there's some missing terms, and there are some terms that need to be reviewed and revised. So that's what issue 7 is all about. And while the paper was out for consultation, we put together a technical group called the Common Quality Technical Group. This group comprises of 11 technical specialists from across the industry, from generators, from Transpower as system operator and grid owner, EDVs, there are suppliers, and there are consultants who are specialists in this field. So we've got 11 specialists in this area, and they have been helping us with this piece of work. We also had system operator. As I said, they have contributed in a huge way to the studies that have been used to inform the options. A lot of work went into the studies. It was over many months. It was not a small job. I'm sure Dr. Vong will be really happy to talk a bit more about the studies. Again, like I said, if you've got any questions, he's your man. But a lot of work went into this. And so a big shout out to System Operator for all their work and the Common Quality Technical Group. Also Professor Neville Watson from the University of Canterbury. I'm sure a lot of you know him. He is a specialist. I'd say he's the leading expert, particularly in power quality. And so he has been instrumental in informing our paper, particularly on harmonics. We've also talked to the EEA. They put out a great paper, guidelines on power quality late last year. That's been very useful. We've worked with agencies like NBIE, WorkSafe. We're keeping the ComCom informed of our work, and ECA. In the area of harmonics, again, there's very little, as I said, and part of it sits under the electricity safety regulations, which is with WorkSafe, and there's a bit in the code. So we've been working with those agencies, other teams within the authority, because we've got lots of work streams happening. Some of it has been used to inform our papers. And lastly, we've also looked at overseas regulators and to see what they're doing in this space. So how did we come to the list that is going to be discussed today, what we call the short list? When we put out the issues paper last year, we then sat with the system operator and worked out a list of options that could be used to address the frequency and voltage issues. Harmonics, like I said, it was a bit too early to look at that. Now, while that was happening, we also developed a set of criteria, evaluation criteria that options could be assessed against, because we knew that the list is going to be too long. We certainly can't address all of them. So we identified 7 evaluation criteria that we were going to evaluate the options against. Now, with working with system operator, we got a long list of 33 options. When we took that list to the CQTG, discussed it with them, and we got another 10. So that was a long list. And that was what we call the long list. We then took those options in the long list and assessed it against the first criteria, which was around feasibility and how long it would take to implement. Now, if it was going to be something that was going to take years to implement or at a very high cost, or the risk of unintended consequences was going to be really high, or it was going to be quite hard to reverse if required, they were pulled out of the list and put into what we're calling a holding pen. That's not to say we're discarding them. We have put them into another area that we need to look at later. What we're focusing now is on what we can do in the next 18 to 24 months. That's what our focus is. So that's gone into a holding pen. We got the medium list. We then took the medium list and then we assessed it against the remaining 6 criteria, evaluation criteria. And all the details of this is in the cover paper. So what exactly the evaluation criteria was, it's all in the cover paper. I won't go into it in detail. So then we went into the medium list and they were assessed, as I said, against the remaining 6 criteria. The options that met those criteria and were not being considered by other work streams in the authority went into the shortlist. And that's how we got the shortlist. So today's presentation is on the 3 options to address frequency issues, and the 3 options to address voltage issues. And then there were another couple of options for issues under 6 and 7. Now, we are also looking at that side by side this, and we intend to come out in the latter part of this year with code amendment proposals to address those issues. Those are, again, options that we consider will not have unintended consequences or are easier to implement. So look out for that paper, which will come later this year. Next slide. So as I said, in April last year, we published the Common Quality Issues paper, and these are the papers that we have been doing so far. Last month, June, we published 4 papers. 1 is a cover paper, and then the 3 consultation papers to address the voltage and frequency and the discussion on harmonics. And as I just said, later this year, we plan to publish a consultation on proposed code amendments to address some of the issues in 6 and 7. And lastly, before I hand over to Philip, how to make a submission. Now, all the papers have got these details in them. Appendix B contains the questions that are being asked that we'd like feedback on. The consultation is open for 8 weeks, so it closes on the 20th of August. And we really look forward to hearing your submissions. Before submissions close, if you'd like to get in touch with us for anything, if you'd like a one-on-one briefing, or you have any questions at all, please do feel free to reach out and contact us. Our contact details are in the papers, but it's also there on your screen. And yeah, we look forward to getting your submissions. So I'll hand over to Philip now to take us through the 2 papers.
Thank you, Sheila. So as Sheila said, we identified a frequency issue, and that is that an increasing amount of variable and intermittent resources likely to cause more frequency fluctuations, and these resources are primarily going to be in the form of wind and solar generation. And over time, this increase in frequency fluctuations is likely to be exacerbated through reduction in system inertia. So through the shortlisting process that Sheila has described, we came up with the 3 shortlisted options that you see on the slide before you there. First one is to require smaller generating stations to assist in managing frequency. So at the moment we have a threshold of 30 megawatts, under which generating stations are not automatically required to assist in helping support frequency. The second one we're looking at is to introduce a deadband formally into the code. At the moment the code is silent on whether or not a deadband is required. And so what we're looking at here is that we put in place a deadband beyond which a generating station must contribute to supporting frequency and contributing frequency keeping and instantaneous reserve. And then the third shortlisted option we're looking at is to procure more frequency keeping to manage frequency within the normal band, which is plus or minus 0.2 hertz around the 50 hertz midpoint. And also to procure more instantaneous reserve to keep frequency above 48 hertz for contingent events and above 47 and 45 hertz for extended contingent events. Just looking first at the first option around getting smaller generating stations to contribute more to supporting frequency, the 30 megawatt threshold that's currently in the code was set a long time ago, going back 20 odd years now. And at the time that it was introduced, the thinking was that it would be a threshold that would be subject to review over time. It's just that that review's never happened. So we're finally at that point now with the introduction of inverter-based resources, the uptake of wind and solar coming down the pipeline towards us, that it's an appropriate time to have a look at that threshold. So the system operator's done a study for us on what would be an appropriate reduction in the threshold, and their recommendation is to go with 5 megawatts. You'll see in the consultation papers there that the difference between a 5 megawatt threshold and a 10 megawatt threshold is not significant. However, for the reasons set out in the recommendations from the system operator, they are recommending 5 megawatts over 10 megawatts. But as with all of these options here, we are seeking feedback. They're just options at the moment. We need to do further work on these before we can come out with a code amendment proposal on them next year. So we're certainly seeking feedback on the pros and cons of what a reduced threshold should be. The next one here, the next option around a maximum deadband, is something that the authority looked at a few years ago. They looked at putting in place a deadband of, from memory, plus or minus 0.025 hertz. And there was feedback, particularly from the generators, that putting in place a blanket, a hard deadband of that level would impose significant costs on them to comply with, or they'd have to go through the dispensation equivalence arrangement process in Part 8 of the code. And that also imposes transaction costs on the generators and also on the system operator. So the authority at the time decided to do further work in this area, and now some years later we're at that point where we've done further studies, and the system operator's recommendation in this area is to go with a deadband of plus or minus 0.1 hertz for new generating units connecting to the system, and to leave the for the existing generation connected, just to leave any deadbands that they have in place at the moment as is. The third option here, just on that, you'll see in the paper there, the authority is basically at the moment of the view that the deadband should probably be the greater of the 0.1 hertz recommendation from the system operator, or if there's an inherent deadband that's in place because of the original equipment manufacturer's specification, then you'd use that deadband instead. So this is explained in the paper, and you'll see our thinking around that. The third option here around procuring more frequency keeping doesn't actually require a change to the code. It's there for completeness, because if we do introduce a deadband, that was expected at least to have an impact on the amount of instantaneous reserve and frequency keeping that the system operator procures. So we've included in the paper for completeness, but it doesn't actually require a code amendment. Thank you. So that's a quick summary of the frequency issue and the three options we're looking at. The other paper is around voltage, and there are three issues here, three voltage-related issues. Thank you. So the first of these is that, again, increasing the amount of variable and intermittent resources is likely to lead to more voltage deviations, larger voltage deviations in the power system. You'll see a reduction in the power system strength, which reduces the quality of the voltage waveform, and as a result of that, we get these deviations. And over time, what we're seeing is changing patterns in reactive power flows, and that's exacerbating this issue, and will continue to do so as you see more reactive power coming into the transmission system from distribution networks. The second of the voltage issue, which we call issue 3 out of the 7, is that the reduction in system strength is also likely to cause performance issues from inverter-based resources, increasing the likelihood of them disconnecting from the power system. And we've seen this overseas, where the settings in the IBR are such that if there's a reduction in the power system quality, the inverters trip, and to protect themselves, the protection mechanisms kick in, and we get disconnection from the power system. And so what we're looking at here is ways in which we can deal with this issue. And then the fourth issue, the third voltage issue, the fourth of the 7 issues, is that over time we're expecting increasing this generation to be subject to the fault write-through obligations in the code. We have a 30 megawatt threshold again in the code for stations to write through faults. That 30 megawatt threshold came about basically to align with the 30 megawatt threshold that's in place for frequency, and also because the authority's thinking at the time was that if we had a number of sub 30 megawatt generating plant disconnecting at the distribution network level, that wouldn't cause any issues for the system. So the system operator's done some studies for us on this issue as well, and that's helped inform our options. Thank you. So the three options we've got are to assign voltage support obligations to some additional parties, to manage the import and export of reactive power at the GXP through better coordination, closer coordination between the system operator and the distribution network operators, and to require smaller generating stations to remain connected electrically during power system faults. The extension of the voltage support obligations is proposed to be to plant connected at the GXP voltage. So that's the voltage on the distribution network side of the GXP. And the basis for this from the system operator study is that if we can keep these plants supporting voltage, that will have a significant benefit in terms of managing voltage on the transmission network. The other recommendation here is that we have these plant operating in voltage control mode, which means that they maintain their voltage at their point of connection to the distribution network as their movements in network voltage. We want to share responsibility between the system operator and distribution network operators around regulating GXP voltage. It's much easier for voltage to be managed closer to the source of the issue rather than further away. And so therefore there's definitely benefits from having your distribution network operators working in this area with the system operator. The other recommendation in this area from the system operator is that we have greater visibility around what's going on with DER and the operating status and the active and reactive power output, and that they have the capability to accept reactive power dispatch instructions from distribution network operators. So I think the important thing to note here is that we're talking about having the capability. We're not at this stage proposing that you would need to be subject to reactive power dispatch. We're just wanting the systems to have the capability if it's needed in the future. When we move on to the fourth issue, which is issue 3 for the voltage, is extending these FRC requirements, the fault write-through requirements, to smaller generation. What we're looking at here is that we would extend them to generation connected again at the GXP voltage on distribution networks. We are interested in feedback from submitters on whether it should be just a voltage threshold, i.e. if you're connected at the GXP voltage, you're subject to the fault write-through requirements, or whether we want to have a threshold which is perhaps a combination of being connected to the GXP voltage and having either a certain nameplate capacity or having a certain net export output, which is the current threshold that we have in place in the code. We are aware of smaller generating plant, sub 5 megawatt plant that are connected at GXP voltages around the country, and so we're quite conscious of not wanting to impose unnecessarily high compliance costs on participants. Vong, have you got anything you want to add?
No, I think you've covered most of that.
I've ended up talking to your stuff. So that's, I think that's, if I'm right, I'm looking to my slide here, sorry, that covers off the issues that we're dealing with, the options that we're putting forward, and the key recommendations that are coming out of the system operator studies. So I think we're open for questions, are we?
Questions?
Thank you very much.
Great presentation. We've had a couple of questions come in, so just a reminder to chuck those into the Q&A. But the first question here we've got from Philip, not this Philip, but another one. If you were going to, sorry, I'll just admit that person into the webinar. If you were going to have embedded plant controlling voltage, will there be a relaxation on the requirements for distributors to maintain power factor? If not, this will entail additional costs for distributors to maintain their power factor.
Oh, sorry, I should have mentioned that under one of the option is to remove the unity power factor obligation in the code that's there at the moment. So that sits in the connection code, which is scheduled to the default transmission agreement, which used to be called the benchmark agreement. So this is in schedule 12.6 of the code if you're interested. And so what we are proposing is that we move to 0.95 leading and lagging for distributors, and we remove that unity power factor to give more flexibility to the distributors. So that unity power factor at the moment applies only for the Upper North Island and Upper South Island during your peak periods. So that's, sorry, I meant to say that. So good question.
Another one here from Joseph. Is there an appetite to look at the steady stage voltage limit of 230 plus minus 6% as the transformer is built as 415 volt at no load? We will give 240 volts. I'm going to get you guys to look at this one because it is a long question and I am not an expert. So this is our question here. Thank you, Joseph.
I think it's around the plus minus 2.
Yeah. 30 volts.
Sheila, do you want to give a politically correct answer to that one?
In one of my slides, I did talk about us engaging with agencies like MBIE and WorkSafe because some of these issues sit in their remit. This is one of those that sits with WorkSafe or electricity safety regulations, and we are, discussing it with them. It isn't in our remit, but we do understand, and the CQTG has raised it, so it is on our list. It is on our radar. We are discussing it with WorkSafe and MBIE.
And just a reminder that the CQTG is the Common
Quality Technical Group. Sorry.
Love acronyms here. Awesome. We've got a question here from Mary Ann. It is a little bit outside of the scope, but we do have somebody here from the system operator, so perhaps we are able to speak to it. Is there any changes to the system operator modelling results now that it is confirmed TY is staying on beyond 2035?
Is it specifically for TY? No, I don't think so. Right, I think the modeling is still the same. It's just a matter of how we do the study, whether you need to consider TY or not consider TY. The system scenario will be slightly different, but in terms of the modeling, network modeling, equipment modeling, it's going to be the same.
Thank you. Hopefully that answered your question, Mary Ann. We've got another question in from this time Darren. Will the wider economic impacts be considered for frequency requirements on intermittent generators? Likely require them to install BESS for reliability frequency response, raising their LCOE to meet these requirements.
The cost of levelized cost. Yeah, basically, yeah.
Stumped up
levelized cost of
the
equipment, basically the return that they'll require.
Levelized cost of energy.
Yeah, that's the cost.
You're going to answer that.
Will the wider economic consider on intermittent generators? Well, I guess the thing is in terms of the I don't think we're intending to design anything that's going to require intermittent generators to have access. That's not what we should be doing here. So we note in the papers that certain intermittent plant tend to run at maximum output, which means that they they can't support under frequency. They're good for over frequency because they can back off. And certainly when we are looking at the costs and benefits of the options, we'll be taking into account the fact that if you were to require plant to have a you might say a margin where they're not running it, so their output is below maximum, there would be an economic cost associated with that in terms of energy into the market and so forth. So we've talked about that particular issue, certainly with the Common Quality Technical Group. And I think one of our options that we didn't shortlist was actually to require the intermittent plant to not run at maximum output if they're wind or basically if they're intermittent. So yeah, I guess it's a long-winded way of saying we're definitely looking at it, we're definitely considering it, and we're not looking at putting in place anything that would require intermittent generation to have a BESS.
Thank you. We've got a question here from Gerard. I think I remember you from our harmonics webinar, Gerard. Embedded generators are 30 megawatts or more. Embedded generators 30 megawatts or more are already subject to the voltage FRT compliance requirements. Are you proposing lowering this threshold?
That's exactly the option, is to reduce that threshold. So that's the third of the 3 voltage options that we're just running through there. Yes. Yep.
All right, we don't have any more questions coming through at the moment, but we'll give it a few more minutes just in case some lingering questions are hanging around. Don't be afraid to ask a question. Clearly, as a facilitator, I don't really know what I'm talking about, so there are no stupid questions here. Did anybody else at the table have any questions?
No, I was just wondering, Vong, if you want to talk a bit about how the studies were, how many were done, and assumptions or anything to that, because that was a lot of work that was done.
Yeah.
There's just a very high-level summary, because there was the TY question, which was
the TY question. Yeah. I think the studies, all the studies we done on, right, is looking at the projection to 2035. So there's a lot of modeling we have to do to get to the 2035. We need to look at what's the connections connection request now and try to project it to 2035, and then looking at what's the generation mix at that time, and all this information is going to our network models. And with that one, right, we start running the study, looking at different options. What happened in the peak load? What happened in the light loads? And for the frequency study, is quite straightforward, because a lot of time we don't need to consider the distribution network. We just can connect the distribution or the DER at the GXP, and we can do the study pretty accurately. The most challenging part is doing the voltage study, and where we want to study what is the effect of transmission system on the distribution network. We end up, we have to extend the network beyond the GXP into the distribution network. And we're quite fortunate, a couple of distributors sort of happy to provide us with the network models, and we get the network models, we connect to a GXP, and then we do the same projection to 2035, and we run the study. And a lot of time we found that try to manage GXP, try to manage distributions is not really that easy, because it's not really the cup of tea for system operators, because we're looking at this transmission network, right? And a lot of time we have to just go back to the distributors to have a discussion with them to say that we have these scenarios, what should we do? And we did a lot of study. We look at the power flow, and we run dynamic study on the fault write-throughs and so on and so forth. And that's challenging, but it's a very, very satisfactory outcome that we get from the study.
Yeah. All right, we've got a few more questions coming through now. Sheila, might be one for you to answer. From Mary Ann. Sorry, I haven't read all the papers. Do the papers include a cost-benefit analysis of each of the options?
Good question, Marianne. Not at this stage. So this is about consulting on the options that we have put forward. And then from the feedback, we will then start going into the next phase, which will be looking at the cost-benefit analysis and finalizing options, which will then feed into a decision paper.
But we do set out pros and cons. So at this stage, these, as Sheila said, these options papers, we're actually looking for input from submitters on the costs and benefits. So you'll see in the papers questions specifically targeted at providing information on what you see are the different costs on different participants of these different options, and also the benefits as well, but particularly the cost side of it. But we, at this stage, it's very much we're trying to get information on the costs and benefits to supplement just the high-level pros and cons that we've set out in the papers.
We've got a couple of questions here around VPPs. So the first one is from Matt. There was a comment in one of the papers about VPPs and whether their aggregated capacity qualifies them as having to meet some of the same obligations. How will aggregators VPPs be included and defined in the code? This seems to cross over a couple of EA work streams.
Yeah, sorry. I meant to mention VPPs as well in my presentation. So yes, in the paper, what we are looking at is the option of VPPs being captured by the same obligations. If you've got a common control system across all of your generation or load, but mainly we're looking at generation, I guess. So if you've got a 20 megawatt VPP common control system, we're saying, well, that should have the same obligations as a 20 megawatt plant that's in one location.
So following on for that, will VPPs greater than 5 megawatts be subjected to the frequency and FRT changes?
Yes, again, that comes back to, again, it's just options. So we're suggesting, though, that if you've got a common control system, then they would be subject, whatever the threshold ends up being. So we don't know yet what that threshold is, whether it's, it makes sense to have the fault ride-through threshold line up with the frequency threshold. We think intuitively we should probably keep the thresholds the same, but we're also thinking that, well, certainly based on the studies, that the fault ride-through threshold should be also linked to being connected to the GSP voltage. So we'll see what submitters have to say.
Can I just add on something on the BPP? BPP is an interesting technology because it's not like any normal technology one, right? It's basically it's self-distributors, can be distributed across the network and all controlled by a single control system one, right? I think it's good to have some sort of regulations or policy to say that how we're going to manage BPP one, right? On the other aspect, that is on the land of system operators one, right? It starts to get very interesting. If you have regulations, how do we check compliance? How do we do testing? What type of testing do we need to do? What type of monitoring we need to do one, right, to check compliance? It's still the early stage one, right? And we're still working through that process and looking at what's the best way to do it. So I think that's maybe the reason that we couldn't give you quite a clear answer because we're still working through the process.
And also frequency differs to voltage, right, for VPP. So we think it's clearer when you're dealing with frequency obligations than for voltage obligations on VPPs.
Our next question is from Gerard again. We would support the inclusion of reviewing Part 8.23 A and B reactive power range requirements at the voltage extremes due to tap changer range requirements and risk of tap changer failure. This has been raised in the past. Will you consider feedback on this in these consultations?
Yes, we definitely will.
Straightforward. All right. Zayad has asked, if these AOPO compliance limits are lowered down to 5 megawatts, would plants that were compliant at the old limits need to re-establish compliance at the new limits? Maybe ask them.
If they comply, then
They comply there.
they comply. They comply anyway. So it would basically be if you're currently under 30 megawatts, you'd need to demonstrate compliance.
Okay.
And just on that point, we've had discussions with the system operator around how that compliance process might work. That we don't want to impose overly burdensome transaction costs on the smaller plant. So we're looking at ways in which modelling requirements may be slightly different, for instance, for the smaller plant. I don't know whether you want to say anything more on that.
No, it's, as I say, it's still the early days. I don't want to bring your hope up, right? It's still the early days that we have to work through it, and we consider all the implications like testing costs and study costs and things like that. What should we do? What is the risk? If the risk is higher, we may impose a bit more stringent requirement. We not try to blanket everything under the same rules, and we try to look at what we can do to lessen the burden.
Yeah.
We've got a question here from John. How many percentage of the future projected DER are less than 30 megawatts?
I don't have the numbers off my head one, right? But at the moment, the entire industry or power system is still very, very fluid and very versatile one, right? Depending on what is the policy and certain, the generation mix may change. I couldn't give you the answer on that one. Sorry.
No worries. If that's something that you would like us to come back to, John, like us a question, we'll follow up after the webinar. Have a question here from Nathaniel. In the slide presented earlier, it was mentioned that existing deadband settings for already commissioned generating units should be maintained. Does this imply that existing stations can still have a deadband settings within the plus minus 0.2 hertz range? Additionally, when referring to new generating units, could we please clarify the definition of new?
Okay. The system operator's recommendation was go with plus or minus 0.1 hertz. The authority's thinking is to go with the greater of that or your inherent deadband from your OEM, your original equipment manufacturer. And our thinking is that would apply across existing and new. So the system operator is saying if you're existing, then just leave your deadbands as are. Our thinking is, well, if you've put a deadband in place that is greater than what your OEM says is necessary or should be in place for the plant, then the 0.1 would kick in. And in terms of whether or not what we mean by new, if there's a refurb, then I think the discussions we've had here is that would basically be captured as new. And we had this discussion at the CQTG, and in particular with the system operator at the CQTG. I'm pretty sure if there's a refurb, then that would be captured as effectively treated as new.
Last question here that we've got is from Jed. Was the frequency droop percentage compliance range 0 to 7% investigated as part of the SO studies?
We considered the droops setting within that range. And just for your information, I think recently we changed the droop to 1 to 7% one, right? And that had been done outside the FSR work. But yes, the studies, when we did the frequency study one, right, we considered droop setting within those range, right?
Did you do 0 to 7 or 1 to 7?
No, I think we average out the droop to be about 3.54%.
Yeah.
Right.
Yeah. So as Vong said, the code has been amended to change that to 1 to 7.
Okay. Another question just in from Robin. Will the performance criteria be monitored, for example, by power quality meters or similar? So will the performance criteria be monitored either by power quality meter or similar?
I'm not sure what you mean by performance criteria?
Yeah, we do check compliance by now all these meter recording, either through SCADA or PMU or ion meters, one, right? Depending on what obligation we're talking about. Some of the steady set obligations, we can use a SCADA. Some of them we may need the ion meters. For example, if we try to talk about harmonics, right, you got no choice. You need the ion meters to go in there, right, with the harmonic modules, right. And if you talk about frequency, right, we do encourage asset owner to install some sort of high-speed recordings. That's good enough for us to measure your performance.
Another question in from Jim. Solar and wind plants tend to be made up of many smaller units, for example, multiple string inverters versus one large inverter. Has this been considered when considering of power megawatts limits for FRT and whether string inverters would be suitable or available?
Let's see how we can answer your question on that. When we request FRT connection study, right, a lot of time the study has been carried out as one single aggregated generators models to represent your whole plant. Personally, when I would like to see all the generators models, because in the plants, right, when you have a FRT study, the voltage distribution is quite different now between the different generators inside the plant. But that will impose quite a high cost to the asset owner. We understand that one. So at the moment, we sort of accept for retro studies to be done using one single generators and not modeling the entire plant.
Right. Thank you, Vong. We have no more questions coming through at the moment, so I'll just throw it out one more time to our panel to see if there's anything else that we would like to chat about. We've got about 8 minutes left in the webinar, but we can always give everyone back a few minutes of their time if there are no more questions from the audience. And while we're here, a big shout out to Rob Mitchell, who is part of the FSR team online, and he's been chucking the links in the chat as the presentation has been going along. So please check them out, and a reminder to jump onto our website and have a look at the consultation page, the 4 papers that include the cover paper and then papers 1, 2, and 3. All the information that you need around taking part in this consultation will be in there. Sheila mentioned at the beginning that if you're keen on a briefing, a one-on-one briefing with the team, just reach out to the email, which is fsr@ea.govt.nz. Yeah, I think that's the one. Yeah, so it looks like we're through with all our questions today. Thank you everyone who has joined us online. A reminder that this session was recorded and we will be posting it on our website as soon as possible. And including the questions. So if you want to share that to any of your teammates that might have missed the webinar today, please feel free to do so. A big shout out to our presenters this morning, Sheila, Vong and Philip. Really appreciate you walking us through this. Is there anything else that we want to highlight before the end of the?
Just thank you very much for the questions, and I hope you found this useful.
Yeah, we're really looking forward to your feedback.
Yes. Absolutely.
Awesome. All right. Ka kite everyone. Have a great day.
Thank you.
Thank you.